In this video, we're going to talk about how to compute the derivatives of several different functions, just doing some examples using the various rules that we have been developing. So let's start by remembering the rules that we have. So we have the power rule, which says the derivative of x to the n equals n x to the n minus 1. We have the exponential rule, which says the derivative of b to the x is equal to b to the x ln of b, where b is some value greater than 0. So we came up with that more extended version in the chain rule video. And then we have the product rule, which says the derivative of f of x times g of x equals f prime of x times g of x plus f of x times g prime of x. We have the quotient rule, which says the derivative of f of x divided by g of x is equal to the derivative of f times g minus f of x times g prime of x, all divided by g of x squared. And then we have the chain rule, which says the derivative of f of g of x is f prime of g of x times g prime of x. Then we also had our trig derivatives, and so just as a reminder of those, the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of cosecant is negative cosecant of x, cotangent of x. The derivative of secant of x is tangent of x, secant of x, and the derivative of cotangent of x is negative cosecant squared of x. So these are all of our derivatives, rules, and properties that we've talked about, as well as the fact you can split up over addition and subtraction and pull out constants. And so we're going to use all of these rules in order to compute some derivative examples. And so we're going to start with the following example. We want to find the derivative of y equals 2x plus 1 to the 5th times x cubed minus x plus 1 to the 4th. And so now with this derivative, notice that we have a product of two things. It's kind of the outermost thing. We have a product of this function, which we'll call f, and this function that we call g. And so when taking derivatives, we kind of work from the outside in. So the outermost thing going on is the product. So we're going to start with the product rule. So the derivative of y with respect to x is going to be the derivative of the first thing, of 2x plus 1 to the 5th, times the second thing, x cubed minus x plus 1 to the 4th, plus our first function, which is 2x plus 1 to the 5th, times the derivative of our second function. Okay, and so we're just using the product rule there. And so now we want to compute each of these inner derivatives, and we're going to use the chain rule for those derivatives. So for the derivative of 2x plus 1 to the 5th, our outer function is to the 5th power. So we're going to 5 times 2x plus 1 to the 4th times the derivative of our inner function, which is 2x plus 1. And then we multiply that by x cubed minus x plus 1 to the 4th. And then plus 2x plus 1 to the 5th times the derivative of the outer function is, the outer function is the 4th function, so we're going to have 4x cubed, but we're going to plug in our inner function, so we have 4 times x squared minus x plus 1 cubed times the derivative of the inner function, which is x squared minus x plus 1. And so we're just using the chain rule on both of those pieces. And now we're just going to take our derivatives. So we're going to have 5 times 2x plus 1 to the 4th. The derivative of 2x plus 1 is just 2, so we're multiplying by 2, times x cubed minus x plus 1 to the 4th, plus 2x plus 1 to the 5th, times 4x squared minus x plus 1 cubed, times the derivative of x squared minus x plus 1 is 2x minus 1. And so multiplying all of this out, we get 10 times 2x plus 1 to the 4th times x cubed minus x plus 1 to the 4th, plus, we're going to pull the constants out in front, so we're just going to have 4 times 2x plus 1 to the 5th times x squared minus x plus 1 cubed times 2x minus 1. And that is about as simple as we can make it without multiplying all of those out. And so that would be our answer for this derivative. So we were able to compute this derivative of a product of two pretty complicated looking polynomials just by using the product rule and the chain rule. So the next example is we're going to have f of x is equal to x squared plus 1 cubed divided by 2x plus 1 to the 5th power. Okay, and so now here our outer function, our outer property is a quotient. We have a function divided by a function. So we're going to start with the quotient rule. So we have f prime equals the derivative of the top times the bottom minus the top times the derivative of the bottom all divided by the bottom squared. And so there, we're just applying the quotient rule. And similar to what we did in the previous example, now we just need to compute these inner derivatives. So we have the derivative of x squared plus 1 cubed. So that's going to give us 3 times x squared plus 1 squared. That's the derivative of the outer function with the inner function plugged in, times our derivative of the inner function, which is x squared plus 1. Then we're going to have a 2x plus 1 to the 5th still, minus x squared plus 1 cubed, times the derivative of 2x plus 1 to the 5th. That'll be 5, 2x plus 1 to the 4th. So that's the derivative of the outer function evaluated at the inner function, times the derivative of the inner function, all divided by the bottom squared. Well, the bottom can be rewritten as 2x plus 1 to the 10th power. You just multiply the exponents. And so here, we just need to compute our derivatives now from the chain rule piece. And so we're going to have 3 times x squared plus 1 squared times the derivative of x squared plus 1. But the derivative of x squared plus 1 will just be 2 times x. Then multiplied by our 2x plus 1 to the 5th, minus x squared plus 1 cubed, times, taking the derivative here, we have 5 times 2x plus 1 to the 4th, times the derivative of 2x plus 1, well, that's just going to be 2, all divided by our denominator, which is x, it's 2x plus 1 to the 10th. So now we're going to multiply things out to simplify. So we're going to have a 6x times x squared plus 1 squared times 2x plus 1 to the 5th for our first term, minus x squared plus 1 cubed times, we're going to have 10 2x plus 1 to the 4th, all divided by 2x plus 1 to the 10th. Now notice there's a 2x plus 1 to the 4th on each of the terms on the top. So we can rewrite this as 2x plus 1 to the 4th times everything else on the top. So we're going to have 6x times x squared plus 1 squared times 2x plus 1. Because we pulled 4 of the 2x plus 1s off. And then minus 10 times x squared plus 1 cubed. So we pulled all of the 2x plus 1 off. Then we have a 2x plus 1 to the 10th on the bottom. And the reason why we did all of that is we can now cancel some stuff. So we can cancel the 4 2x plus 1s on the top with 4 of them on the bottom. And so we're just left with 6x times x squared plus 1 squared times 2x plus 1 minus 10 times x squared plus 1 cubed, all divided by 2x plus 1 to the 6th power. And so that then is our derivative for this expression of x squared plus 1 cubed divided by 2x plus 1 to the 5th. So now let's look at our next example. So we want to find the derivative of g of x equals 1 plus cosine squared of x cubed. And so we now look at this expression and we see, okay, the outermost thing that we're doing here is cubing. And so since that's our outermost thing, we're going to start with the chain rule in finding the derivative. And so we're going to use the chain rule. So the derivative of x. By the chain rule, we're going to have the outer function's derivative, which is the cube's function's derivative. So we're going to have 3 times the derivative, well, 3 times the inner function, which is 1 plus cosine squared of x squared. So this is our f prime of g of x. G of x having a different meaning here, but that's the derivative of the outer function with the inner function plugged in, times the derivative of the inner function. Okay, and so from here we need to compute that second derivative. So we're going to have 3 times 1 plus cosine squared of x all squared times, now we need the derivative of 1 plus cosine squared of x. Well, cosine squared is a composition with square on the outside, so we're going to have 2 cosine of x times the derivative of cosine. So that's just using the chain rule. The derivative of 1 is 0, so we just really were taking the derivative of cosine squared. So we get 2 cosine of x times the derivative of cosine. And so we have 3 times 1 plus cosine squared of x, all squared, times 2 cosine of x, and then the derivative of cosine is negative sine. And so multiplying this all out, we are going to have a 3 here with a 2 there, and a negative sign, so we have negative 6 times 1 plus cosine squared of x, all squared, and then times sine of x times cosine of x. And so that is our derivative for 1 plus cosine squared of x all cubed. And we were able to compute this derivative just using the chain rule twice. Okay. So now our next example is we want to find the derivative of x squared sine of e to the x. So we look for our outermost thing that's going on. We've got this product of two functions, the x squared function and the sine of e to the x function. And so we are doing a product rule first. So we have the derivative of the first function times the second function plus the first function times the derivative of the second function. So that is the product rule. Now the derivative of x squared is 2x, so we have 2x times sine of e to the x plus x squared times, now we need the derivative of sine of e to the x. Well, this is a composition where cosine is the outer function and e to the x is the inner function. So the derivative of the outer function is cosine, plugging in the inner function of e to the x, times the derivative of the inner function, which is the derivative of e to the x. And so multiplying this out, well, doing the derivative, we get 2x sine of e to the x plus x squared cosine of e to the x. And then the derivative of e to the x is e to the x. And so we got 2x sine of e to the x plus x squared cosine of e to the x times e to the x. And so that is our derivative in that case. So now for our next example, we want to find the derivative of y equals secant of 5 to the x divided by x. So we look for the outermost thing going on. The outermost thing going on is we've got a quotient of things. And so we're going to use the quotient rule to start with. So we get dy over dx is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. Now we compute this derivative. The derivative of secant of 5 to the x is going to require the chain rule. So we have the derivative of secant, which is secant tangent. So we have secant of 5x tangent of 5x times the derivative of 5 to the x. And then times x minus secant of 5 to the x times x, but the derivative of x, but the derivative of x is 1. So we just have a 1 there, and then we've got divided by our x squared. So now we need to take the derivative of 5 to the x. So we're going to have secant of 5 to the x, tangent of 5 to the x. The derivative of 5 to the x is 5 to the x times ln of 5 times x minus secant of 5 to the x, all divided by x squared. And this is about as simple as we can write it. And so that right there then is our derivative of secant of 5 to the x divided by x. So now we want to look at one final example. And so we want to take the derivative of sine of 3x plus 1 divided by 4x plus 2. Okay? So we want to compute this derivative of sine of 3x plus 1 over 4x plus 2. So to do that, our outermost thing that's going on is a composition of sine with something plugged into it. And so we're going to have the derivative of sine, which is cosine, with the inner function plugged in. And we want to do times the derivative of our inner function. And so this is just the chain rule. So it's the derivative of the outer function, which was sine. So we get cosine of the inner function, which is 3x plus 1 over 4x plus 2, times the derivative of our inner function of 3x plus 1 over 4x plus 2. So So we have cosine of 3x plus 1 divided by 4x plus 2 times the derivative of our function. So we have the derivative of, we have a quotient here. So we take the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So let's actually compute these. So we have cosine of 3x plus 1 divided by 4x plus 2 times the derivative of 3x plus 1 is just going to be 3. So we get 3 times 4x plus 2 minus 3x plus 1 times the derivative of 4x plus 2, which is just 4, all divided by 4x plus 2 squared. And so this is cosine of 3x plus 1 over 4x plus 2 times, we're going to have 12x plus 6 minus 12x minus 4, distributing the negative, all divided by 4x plus 2 squared. Now we have a plus 12x and a minus 12x, and plus 6 minus 4, so that leaves 2, I guess. And so we get cosine of 3x plus 1 divided by 4x plus 2 times 2 divided by 4x plus 2, all squared. And so that is our derivative for sine of 3x plus 1 over 4x plus 2. And so in this video, we've been able to compute the derivatives of a number of complicated looking functions just using all of the properties that we have talked about.